Hello everyone, today I'm very excited to give you the first preview of function execution with the Keptn Lifecycle controller. The Keptn Lifecycle controller is a new project under the hood of the Keptn organization, which helps you ensuring that your cloud native applications are running perfectly fine. So when we are dealing with Kubernetes, we are often deploying workloads such as deployments, stateful sets and daemon sets, and we might have many of them which could be grouped into applications. The Keptn Lifecycle controller can enhance everything we know from these workloads by adding pre-deployment checks for your workloads, but also on an application level, but also adding post-deployment checks for your workloads, but also applications. Furthermore, it's able to run application and workload health checks. So these are all nice things, but what can we do with it? So for instance, for pre-deployment, we can run some security checks, we can do some infrastructure checks, such as finding out if the infrastructure is ready for deploying on it. We could check for problems in our observability provider, but also check for open issues in our issue tracking system. For post-deployment, we could do some functional tests, we could do performance tests, but also SLO validations and notifications. And last but not least, for the application and workload health checks, we might be able to run notifications on pod restart, but also create service tickets on error. So these are all nice things, but we need some layer where we can execute things. And this is all about task execution, and for the Keptn Lifecycle controller, we plan this using functions, containers, and other things. And this is what our demo is about today. So, in my demonstration now, I will simply trigger a TypeScript function by applying a manifest to Kubernetes, and afterwards take a look if this function has finished successfully. So to get to the code, I have my task definition here, which has a kind of Keptn task definition, obviously, which is called hello Keptn inline. And this has a specification, and in the specification we see that this will be a function, and we reference to this function inline. So we have the function in our custom resource definition. And this is a very easy function, so this simply gets some data from an environment variable, which is also specified in Keptn. We will get the JSON data from this environment variable, and afterwards simply log out hello and the name which is specified in there. This task definition can be referenced in tasks. So we have a Keptn task here, which is called hello developer inline. This is using the task definition we created before. It will be relevant for the workload my workload. This will have the version 1.0, and this will be for the application my app. And these are the parameters we saw in the data JSON object before, and we say yes, the name of our developer is the Keptn developer 1 today. So let's simply apply this. So what we see here is I have exactly the same things as we saw in the repo before. When I take a look at the task definition, this is exactly the same object and the same for the task. And let's simply apply this on our Kubernetes cluster. And we see that we created a new Keptn task and a Keptn task definition. And now we just can take a look if everything, how the state of the task is. And we see we have our task hello developer inline for the application my app, for the workload my workload in the version 1.0. This created a Kubernetes job with this name, and it has succeeded in the meanwhile. So if we take a closer look on the job name and the corresponding pod for that, we also see that this printed out Hello Keptn Developer 1 new, and when the state of this task and job is succeeded, then everything is okay for our Keptn task, and in the future our Keptn Lifecycle controller will be instructed to run the deployment, or to say that the deployment has finished in a post-deployment scenario. So getting back to the slides, there are some additional features we have in the function execution layer at the moment. At first, we can also reference to functions on HTTP servers, so you don't have to specify your functions inline. You can also have them lying on an HTTP server and execute them directly from there. Furthermore, you can reference to other task definitions. For instance, you can have your template function where you simply specify a link to your HTTP server or to an inline function, but also could pass more specific parameters into another task definition and reference to that. And last but not least, we are also able to add Kubernetes secrets to them to pass more secure data over to the functions. In the future, and for the Keptn Lifecycle controller, you will be able to reference to such task definitions in your workload annotations, and you won't have to deal with the tasks by themselves on your own. So if you think this is a cool thing and you want to help or contribute to the Keptn Lifecycle controller and to the function execution, here are some links. So what you see here is work in progress. So this is the first pull request for that. We have a separate working group for everything which is related to the Keptn Lifecycle controller, but also for application lifecycle. You can find the link to the GitHub repository here. You can always share your thoughts with the Keptn community, and you can always ping me on the Keptn Slack. And furthermore, last but not least, we have Slack channel for the app lifecycle working group also on the Keptn Slack. And we could make it better together. So if you think you have cool use cases you want to fulfill with the Keptn Lifecycle operator, I'm very excited to hear about your opinions. And last but not least, if you have some issues or want to implement something, I'm always happy to accept pull requests, and it would be really nice to hear from you. So thanks for your attention. My name was Thomas Schütz, I'm a Keptn maintainer, and I hope to see you soon. Thank you.